Math 2414, Power Series, Video 7, 5th example. All right, well, it says it all. 5th example, let's take a look at it. Find the interval of convergence and the radius of convergence for the following power series. The sum from n equals 0 to infinity of n times x plus 2 to the nth power over 3 to the n plus 1 power. Well, same story as before. We're going to set up the ratio test, set the limit less than 1, solve that absolute value equation. If the interval is anything besides the center only or all real numbers, then we'll check each endpoint of the interval for convergence. So let's set up the ratio test. We're going to let L equal the limit as n approaches infinity of the absolute value of the next term times the reciprocal of the current term. Since our terms are already fractions, there's no need to put one on top of the other. We'll go ahead and reciprocate the current term that's in the bottom of that ratio. All right, so our next term is obtained by replacing each n with an n plus 1. So instead of n, we have n plus 1 times x plus 2 to the n plus 1 over 3 to the n plus 1 plus 1, but that's just n plus 2, times the reciprocal of the current term. So we just write that upside down. 3 to the n plus 1 on top, n times x plus 2 to the n on the bottom. And we start our cancellations. Starting with the x plus 2's, all of these cancel all but one of those, since n plus 1 minus n is 1. So we're left with an x plus 2 on the top. As far as the 3's go, since this exponent minus this exponent is 1, we will have 1 3 left over in the denominator. So this cancels this and leaves a 3. And the n's won't cancel. I know some of you are going to attempt to do this. Don't do that. You cannot cancel parts of addition or subtraction problems in a fraction. Fractions are division problems. The opposite of dividing is multiplying. This n is not multiplied. It's added. It's not eligible to cancel. So we're left with these guys, but it's not the end of the world. Let's gather every factor that doesn't have an n and put it outside the limit. That would be the x plus 2, which is still in an absolute value. The 3 on the bottom, but the absolute value of 3 is 3, so we don't need its absolute value. But you know what? If you weren't sure, if something is inside an absolute value and you're not sure if you can pull it out of the absolute value, leave it inside. There's no shame in that. And then the limit as n approaches infinity, the absolute value of n plus 1 over n. But this is a limit we've seen before. It's just the limit of the ratio of two polynomials. The degrees match, so the limit is the ratio of their leading coefficients, 1 over 1. That limit is equal to 1. And so we have the absolute value of x plus 2 over 3 times 1, but anything times 1 is itself. So there's our limit. Now we just have to put that less than 1, solve the following inequality, and check the endpoints for convergence. All right, so let's solve the absolute value of x plus 2 over 3 is less than 1 by sandwiching x plus 2 over 3 between -1 and 1. If we multiply everything by 3, we get -3 is less than x plus 2 is less than 3. And then if we subtract 2 from everything, we get -5 is less than x is less than 1. So far what we know about our interval of convergence is it starts at -5, ends at 1. Guess where it's centered? You shouldn't have to guess for 2 reasons. Number 1, the center is the average of the endpoints. So if you add -5 and 1 and then divide by 2, you'll get -2. But I should have asked you at the beginning, what's the center? Because the center is what's being subtracted from the x. And I know that says plus 2, but it's the same as x minus -2. So the center of this was destined to be at -2. But without the radius of convergence, the center doesn't do us much good. Oh, but now we know the radius. And it kind of bothers me, and this is my own fault, that the question, I take that back. It does say find the interval of convergence. That means check the endpoints. For some reason, I keep thinking it's just asking the center and the radius. We have the center. The radius is how far this is. That's just 3. 3 to the right of -2 is at 1. 3 to the left of the 2 is -5. But we don't know what happens at -5 and at 1, so we have to check those individually. Let's check x equals 1, going back to our original series, which was the sum n equals 0 to infinity of n times x plus 2 to the n over 3 to the n plus 1. But we're letting x equal 1, so we'll put a 1 here where the x is, or where the x was. That gives us the sum of n equals 0 to infinity of n times 3 to the n over 3 to the n plus 1. So we got a lot of canceling 3's. These n's cancel, these 3's cancel most of those that leave 1 behind. And we have the sum of n equals 0 to infinity of n over 3. So will this series converge or diverge? What do you think? It's got to diverge. The test for divergence, that's a key one to remember. The test for divergence says if the individual term does not go to 0, the series must diverge. Notice that the limit as n approaches infinity of n over 3 is not equal to 0. It's infinity, if you will, but it's not equal to 0, and that implies that the series diverges. By the test for divergence. Test for divergence should really be the first thing you ask yourself. What happens as n approaches infinity of that? If the answer is not 0, shut it down, the thing diverges. All right, so we got divergence for x equals 1. But what about the other end of the interval at x equals -5? Well, when x equals -5, our series becomes, let's see, it was n times x plus 2, so -5 plus 2 to the n over 3 to the n plus 1. That's the sum n equals 0 to infinity of n times -3 to the n over 3 to the n plus 1. And now might be a good time to separate the alternator from the 3. Because I'm looking to cancel things, but right now my 3's aren't the same, so I can't just arbitrarily cancel them. But if I split the alternator off the 3 and leave the 3 with its own nth power, then the bases match here, and so we can consider canceling. These 3's cancel all but one of those, and we have the sum of n equals 0 to infinity of n times -1 to the n over 3. Well, it's an alternating series, but just like before, the nth term does not go to 0. The limit as n approaches infinity of n to the n times -1 to the n over 3 is not equal to 0. Because if you just took the even numbers, even powers, you would get a bunch of numbers going to positive infinity. If you took odd powers, -1 to an odd power is -1, you'd be getting a bunch of values going to negative infinity. But if you're going off to infinity, it doesn't matter which one it is, you can't be getting closer to 0 at the same time. So we get divergence for the same reason as before. So here's an example of an interval of convergence where we get convergence on neither endpoint. And so we can wrap this problem up. Therefore, the series converges on the interval -5 to 1. The center was -2, the radius was 3. Oh, by the way, speaking of convergence at endpoints, you cannot assume, oh, if one converges, the other one diverges, or that they both converge, or they both diverge. In this case, we got divergence at both endpoints. I've seen intervals where we get divergence of both endpoints, this one. divergence at one endpoint, convergence on the other. See previous examples. And I've seen intervals where you get convergence on both endpoints. So you can never assume anything. You have to check each endpoint individually.